Hey guys, and welcome to Top Channel 1-on-1. So there is a new version of Blender, which is Blender 4.3, and with it comes with the new Foreach loop. This is in addition to the other loops or zones that exist in Blender, including the repeat zone and the simulation zone. Now we have the Foreach loop. What is interesting about this is that you can even nest these loops. For example, to create these explosions, I nested the Foreach loop that you can see here for each element in the repeat zone to be able to create these exploding effects from the movie Inception. I'm a big fan of Inception, especially this scene where DiCaprio starts to explaining to her that they're inside a dream. She panics and then the world around her starts exploding. That's the thing I was trying to replicate here, and the Foreach loop really helps a lot here. I'm working on a course that explains this in detail, step by step. I'll be making that live very soon, and if you want to get the geometry node set up as well, I'm going to be leaving links in the description. But so the way the Foreach loop works, it works with a group or collection of different elements. For example, let's bring in a Suzanne head here. A Suzanne head is made out of faces, edges, and vertices. So if we set up a new geometry nodes and bring in the for each zone here, you can see it works per element. So this is for each element, and you can select what element you want. To demonstrate what this does, we're going to run this for each loop on the Suzanne head and check the area of the face, and if it's too large, we can say delete it. And so let's jump in here and change this to faces. Now I need to bring this geometry in and connect this to this. You can see there are two outputs. The first one is going to be the original output unaltered. So whatever you feed in here is basically what you get here. And then this other one is the results of the for each loop. Let's get the area, the face area. And if the face area is greater than, let's say 0.5, let's delete that. So I'll plug this in here, and I want to delete faces and connect that. Let's see the face area. So yeah, you can see that it's now deleting any faces that are too large. Now this looks like something we could already do without this. So if I just bypass everything here and just use a delete faces by area, face area, an area that is greater than. So basically we can achieve the same setup by doing this, but the only difference here is that this is working on the geometry as a whole, while this is working on individual faces. So it's basically running the whole operation, this entire loop per face. So it starts with a face one and then goes to the next, to the third, fourth, every time. And this loop runs as many times as you have the elements. So for example, this has about 507 faces. So this loop is going to run 507 times. And the way you can even see that is if we preview this, the results are not going to be the same as this. If I add a subdivision surface, you can see that this is getting subdivided as a single mesh. But if I take a look at this here, you can see now these are individual faces because this is running on per element. So if we change this to points, you can see that it's going in, extracting the particular element, for example, points, running the loop on that point and doing whatever you want to do on it. So for example, if we change the position, let's say move this up, it's going in, moving that particular element and repeating the entire loop for every element. So it goes to element 1, 2, 3 up to the last one. We're doing all the operations here and outputting the results. So if it's faces, it's extracting a single face, doing all the operations you want and outputting the face here, but in the same position. So if you don't have anything like subdivision, you may not even tell that these are individual faces. So it's extracting whatever element you're working with, working on that particular element, and then repeating the loop for the next element and the next and the next and the next until you are done. That's how we end up with something like this. Now that is very useful, and in this demo here you can see how I set up something for fracturing objects You can check out this project file. I'll be leaving links in the description to explore how I set this up. But this was just a demo to show you how powerful the for each loop is, because you couldn't do this with any other zones. We have a repeat zone, we have a simulation zone, and none of those could achieve this. Let me show you here on a cube, and let me have another mesh here and displace this randomly. So I'm trying to fracture this mesh. Let me use a solidify modifier here just a bit. Okay, so if you're using a boolean modifier and select this as, let's use first. Now let me change this to wireframe. You can see that basically what I'm trying to do with geometry nodes and the repeat zone is basically this setup. So I have an object and use a cutter object like this here and cut the cube. Now, when you cut a cube like this or any mesh like this using a cutter like this, you'll have two parts of the mesh. You have this side and this side. Now, this is where the for each loop comes in handy. And because we have divided this into two parts, we can run a for each loop on both of these elements. So after this is done, we end up with two pieces, one like this and one like that. The for each loop makes it possible to run the same operation again. So the same operation would be to have a cutter like this, place it somewhere randomly and maybe even rotate it, and use a boolean node to again repeat the operation. And now we have another cut. Let's say we apply this, and now we have another piece just like this. These are now three elements, so we can run the for each loop for each element. So each element would be cut again. This cuts this, and again repeat the operation for this element. And basically that's what I have for these objects. So if I close in on this, let me make a copy here. The great thing about the for each zone is that you can even nest it within a repeat zone. So basically what is happening with this setup is the for each loop finds an object like this, which is just a simple object like this, creates a cutter and splits it in two instances. And because we are running this for each on the number of instances we have, we begin with only one instance. And when that for each loop runs, it runs for each instance. And when it finds one instance, it just runs that one time. Then this repeat zone is just there to make sure that the for each loop runs again, because the for each loop can't run again if it doesn't have any more elements. Since it has only one, it will stop just there. This is just to tell it to do it again. It starts here with one element, does all these operations to create a cutter like this, uses that cutter to split the mesh using booleans. So it would split it once like this, then it stops. But now we have two instances. We have one, we have two, but it won't run again because the input only had one instance. The original instance, we fed it in. To force it to repeat again for these two instances, we nest this for each zone in the repeat zone, basically commanding it to repeat the action. But this time with two instances, those instances are going to be fed back into the loop. And now this for each is going to run on those two elements. It extracts the one piece, splits it into, so we would have like two pieces. And the way this for each loop is working, every time it runs, let's say here, this cutter is rotated randomly and randomly per element. Now when we split this, you can see that it goes on to this half here. It rotated this cutter somewhere like this to get this crack here. And remember, assume this half is not there at all. And actually I think we can even delete let's see, delete the instance here. Let's see, instance index equal to 1. So I've deleted the first half. Remember, when this runs the first time, it creates two instances. It creates this one and this one. When we run it again, every time this for each loop runs, it's extracting a piece like this and does all these operations, creates the cutter. For this, I think it rotated it somewhere like this and output that here. But again, If I disable this, you can see it ran for this piece and this piece, each time cutting them separately and also rotating the cutter randomly. So for this piece, it rotated it this side. So that's why you see that we have a lot of different cracks happening. If we run it again, it's going to run for those individual pieces. And if I bring this back again, I can you can see it's running on this piece and creating new cuts. When you do this again, it will do another cut and another cut and another cut until you have very many cuts. Basically, that's why it is nested into the repeat zone, because it only runs once, and initially we start with one instance, so it will run for that instance, creates two cuts and stop. So to force it to do this again, we have to nest it into a repeat zone to repeat the action for the number of instances we have produced, and it will do that over and over until the number of iterations you have here. So that's how we end up with this. Then this part here is just to set up a few things, like so we end up here. If I use a scale elements, you can see the different pieces we have, but the problem is that their pivot point is at the center. If I try rotate instances, you see that they're all being rotated from the center. So this setup here is just to make sure that each piece has its own center at the center of the geometry. And again, we are using a for each loop for each element. And let's see, delete geometry. Let's see if I can just get that single one. Yeah, you can see we are working on one piece and just trying to calculate the center is center. Basically, that's what this setup is doing. And then we set up some animation for the explosion, and that's it. This is just one use case for the for each loop. There are so many ways you can use it. It's really, really a powerful tool that I think a lot of you are going to find useful. Again, if you want to check this project file, links are going to be in the description. I'm working on a geometry nodes course that is going to be way more detailed, explaining step by step, and not just for the for each loop, but for a lot of other things and nodes that could be useful to you. So if you want to check that out, make sure you turn on notifications. I'll be releasing it within a few weeks. So thanks for watching. See you in the next video.